So ways of solving quadratic equations. Use up a whole sheet of paper. My intention with this tree map is to give you an aerial view of what we're doing and where we're headed. This is kind of like a big panoramic view of what we've been doing and where we're going to go on Monday before I leave to Phoenix. So I'll give you a minute to copy this down. We're going to talk about this. Okay, so what do I mean by isolating x, factoring, completing a square quadratic formula? Phones away. I have the floor. Phones away, earphones on. Very simple. I see it on still. That's it. Yeah, just go and turn it off. The phone is maybe different. Thank you. These are 4 ways of solving a quadratic equation. You already know how to isolate x if I throw a quadratic equation. You already know how to factor, use a factoring method to solve it. And we just completed this here, completing the square method. All 3 of these methods are under your belt already. We haven't spent too much time on this one because it's so easy, and you'll see why. Monday's lecture is the last and final method before your first exam, next Friday. Okay? I saved the best for last and the most powerful for last. And for most students, the scariest for last. There's nothing you can't handle without my help. Figure it out. Isolating x. When do we use this method? So we've got 4 methods here. When do we use this one? Here we go. Underneath, you're going to write use when there is no bx. When there's no bx. Now, what do I mean by bx? I mean the standard form of quadratic. Remember ax squared plus bx plus c? That's what I mean. So we use this method. If you have no bx in the quadratic equation, you can use the isolated x method, the standard method, in other words. Let me show you what I'm talking about. What if you have x squared, Gonzalez, equals 36? Is that or is that not a quadratic equation? Can someone provide a simple argument for why what I'm pointing at right here in green is a quadratic equation? Right, that's the variable is the second power. It satisfies the definition of a quadratic equation. Okay, let's get x by itself. How would we get x by itself? Square root both sides. So notice, all I have to do is get x by itself by square rooting both sides. Notice there's no bx in this equation. There's only an ax squared here, right? So this method of solving quadratic is the easiest of all of them. Let's do what Mr. Rojas said. Let's take the square root of the left, square root of the right. That gets rid of the second power. X is by itself. We're in business. What is the square root of 36? And negative 6. Remember, there's 2 of them. Done. We just solved a quadratic equation, an easy one without bx. Okay? So far, so good. All right. Next method. By the way, notice why I haven't spent so much time on this. It's so easy. The bulk of our time has been here and here so far. Okay, stay with me. You guys have been good for today. Factoring. When should we use factoring? Well, if you do have a bx, that's when we got to factor. Let me give you an example. X squared plus 4x plus 5. No, my bad. Forgive me. X squared plus, let me give you a better one there. X squared plus 4x plus 3 equals 0. We can solve this by factoring, because if we did the discriminant would result in a perfect square. Let's get right to the factors. Let's do it. What would go what, where, and where? 3 and 1, beautiful. Plus 3, plus 1 to make the 3, and an x here to make the x squared. Outsides and insides add up to be 4x. You can check it if you want. I'm not going to check it if I know it's right. Knock yourself out, though, if you want. Right? So now what do we do at this point? You guys remember 2 weeks ago? Or the beginning of last week and the week before that? What do we do now? We don't get all happy because we have the factors. Now what? What do we do? By how, Mr. Rojas? Perfectly said. So in other words, set each binomial equal to 0 and solve for x. So let's set this binomial equal to 0 and this one to 0. Remember we did this? Some of you are still on that assignment. Look what ends up happening. I'll subtract 3 from the left and from the right. So one solution is -3. And the other solution is going to be -1. Okay, that should ring a bell. We worked on that 2 weeks ago and the beginning of last week before we got into completing the square. Again, we can only use this method, factoring method, if the discriminant allows us to. Remember, we discriminate whether we can or cannot factor. This is the discriminant gives us a green light. Do it. Third method is that you're no stranger to the third method. We've been doing that for the past 2 days. I'm going to use the same equation for the third method right here. Watch. The same equation for factoring, we're going to do it with the completing the square. Look at x squared plus 4x plus 3 equals 0. Let's do the same equation but different method. We'll get the same solution. Watch. Is A 1? A is 1. Beautiful. Let's get rid of C. Do it with me. Get rid of C first. So I have x squared plus 4x equaling -3. You guys with me, I trust? Now we'll add b over 2 squared to both sides, right? I'll put that in red real quick here. So b over 2 squared, let me calculate that. That'll be, let's see, 4 over 2 squared. Because b is 4, that'll be 2 squared, that'll be 4. So let me add that to both sides. I'll add a 4 to the left, add a 4 to the right, and let's see what we get. X squared plus 4x plus 4 equals, I should have put a 4 here, my bad. Negative or positive 1, I guess. -3 plus a 4, positive 1. Now, if you take the sign of a bigger number, here we go, positive 1. Here we go. Now we factor the trinomial on the left, right? This is completing the square. So x plus 2 times itself. Look at that. Yeah? Again, if you don't have the same binomials, Rolon, then something went wrong. So a binomial times itself is really logically, just thinking logically means that. Anything times itself is to the second power, by definition. Now let's square root. You guys with me? The square root and the square get rid of each other, so I have x plus 2 equaling the positive and negative square root of 1. But what is the square root of 1? That's actually a perfect square. 1 times 1 is 1, and -1 times -1 is +1. So watch this. X plus 2 is actually equal to positive and negative 1. Right? Think of it logically here. So this one just so happens to be a perfect square. That's okay. Let's keep going now. X is not by itself. Let's subtract 2 from both sides. X then becomes negative 2 plus 1 and negative 2 minus 1. Notice how one of the solutions is a plus 1 and the other solution is the minus 1. Remember, a quadratic equation has 2 solutions. So that means then x is what? What is negative 2 plus 1? Negative 1. And negative 2 minus 1? Careful. What's negative 2 minus 1 to be the same as negative 2 plus negative 1? What would that be? Negative 3. Isn't that the same solutions that we had over here? Look at negative 3 and negative 1. Same solutions using factoring, but now here we use completing the square. It's a different method. Same equation, 2 different methods. Okay? So the cool thing about this tree map is it kind of gives you an aerial view of what we've been doing. And now where we're headed on Monday, the last and most potent, most powerful method of solving a quadratic equation. In other words, this method I'm about to introduce you to that I trust will not give you nightmares over the weekend. This method steamrolls over all 3. In other words, if you memorize this last method, you don't even have to worry about any of these methods because they work for any quadratic equation that's ever thrown at you. It's that powerful. It's kind of like if you're in a war, you have little pistols and grenades, and you bring out the big gun. This last one's the big gun. It'll obliterate any quadratic equation that's ever thrown at you. Just steamroll it. Ready? What I'm going to do right now is I'm just setting you up for Monday's lecture. I'm going to give you the formula, and then Monday I'm going to give you some examples of how to use it. And we're done for the day right now. I'm just going to give it to you now. Ready? Don't get scared. It's going to be okay. Before I write it down, notice on the first 3 branches, every single end, we always ended it with what? X equals. X equals. X equals. Because we're solving, look at X equals. We're solving quadratic equations, so we want to know what the solutions are. X has to equal something. So now look at, here we go. Last one. Some of you may have seen this before. It'll ring a bell. Some of you have had a long, meandering, winding road kind of math journey prior to me, and so some of you may have seen this one I'm about to write down. Ready? Again, they all start off or end with x equals. Look what I'm going to start off with. X equals, this is quadratic formula. Negative b plus and minus the square root b squared minus 4ac all over 2 times a. Monday, I will go into examples of how to use this. It looks scary. It looks scarier than it actually is. It's not a big deal. Okay, so what you're looking at in this big tree map, this 4-branch tree map, is actually a summary of next Friday's test. You'll have to know how to do all 4 for the test. Okay, so it's like a big setup for next Friday. Next week, we'll be focusing on this method and finishing up this method, because some of you still have to finish the assignments on completing the square and practicing that. But the bulk of next week with a substitute, we'll be working on this. And she'll be playing videos for you. I'll be calling him or her, whoever it is, from Arizona, making sure you guys are not abusing her or him. FaceTime, there you go. Hey, we should do that, huh?